Well, hello and welcome back. Let's do a little bit of Go coding, shall we? Just check my mouse. That's a good indicator, you use your mouse, and if the mouse is slowing down massively, just the stream's not working. Let's stop my country and western because I really can't talk and listen at the same time. I'm just not capable of doing it. Okay, right, let's head over what we're going to have a look at. I thought we'd have a look at comparison operators because it's definitely something that I need to have a think about. Once again, from the live stream that I was doing the other day, it's about looking at this comparison with equals operators. This is not just a Go thing. All languages have some quirks around equals. You look at Java, which has a dot equals method rather than it promotes that more than using the double equals. You look at JavaScript, which has like equals, double equals, triple equals, and all the other in betweens. JavaScript also has some good libraries for deep comparison as well. So every language has got a quirk. Think about it. If you think about an object that has got an array, which has then got a slice, which has got dynamic types in there, you're expecting a lot to say that this object double equal signs this object, and for that to be truthy. You're asking a little bit much of the library in order to do that. And this came up because I just really didn't understand this. And forget whether the logic is right or wrong. Better people than I are going to work that out. But from a coding point of view, we're looking at something, and what we're doing is we're actually checking here, and we're saying, look, if the object is nil, well, we're all used to that in GoLang. I think most of us have got it on some kind of shortcut. Or if the object is equal to its default state. Now this is interesting because other languages have like a type dot default or even just a default keyword, which allows it to create an instance and then allows you to do some kind of comparison operator on it. Well, Go doesn't really have that, and other languages don't either. So what we can do is we can use reflection deep equals, which I covered in a previous video, so I'm not going to go into that. But it got me thinking about comparison, and it got me trying to wonder whether there's something else going on there. So if I have a look down, people are obviously asking about guarded clauses. There's a link somewhere that was really good. I wonder if it's just in the code itself. Come on, where are you? We're in the pull request. That's the guarded clause. We all know about guarding. Just bear with me. There's a link that he provided. Might be in one of the discussion points. What the hell's it gone? Looking at the same code over and over and over again, expecting a different outcome. Let me see if I can find it. GoLang comparison. This might be it, Let's see. Yeah, I think it might be it. I don't know where it's gone as far as this pull request. Jesus, I'm blind. Absolutely blind. Which is why I'm not a great fan of PRs, probably because I'm daft enough to just not look at things properly. I don't know what it is. Anyway, here we go. Let's have a look at this stinker. Change its options, make sure it's at least visible to both you and I. Let's see what we've got. So we all know about comparison operators, right? Equals, not equals, less than, greater than, is greater than or equal, and blah, blah, blah. They're just an equality check. So if you have an int, you can do int equals, is int equal to this int, or is string equal to this string? I'm not going to get into string comparisons because that's impressive that a language has the ability to do a string comparison. It's not as easy as you think. Pointer types are comparable. So that's good, which is what we need, especially in this example, because that example was a pointer reference to a new object state. So that is comparable. Channels, values, struct types are comparable if all their field types are comparable. So two struct values are equal if the corresponding non-block field values are equal. The fields are compared in source order and comparisons stop as soon as two field values differ. So it's not, the algorithm's not going to just go and check through absolutely everything. As soon as it hits a point in the object where it's different, out it pops. Array types are comparable if their array element types are comparable. Right? Can you just give me a list of stuff that's not? You know, you're telling me this is, if this is, you know, what's not? Or have I skipped it? I think I remember that slices and comparable or something like that, which, you know, think about what a slice is doing. I'm surprised it works in the first place. The fields are comparable in source order. Yeah, blah, 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 blah. Two array values are equal if the corresponding elements and values are equal. The elements are compared in ascending order. Comparison stops as soon as two elements differ. Or the elements have been compared. These types are comparable if they are strictly comparable. See above. Okay. Not. Why is my the search doesn't work in this view? I have like Vim plugins, blah blah blah. But they don't work when in this kind of, you know, this little viewer. So slices are not comparable. This is not comparable. Slice, map, and function types are not comparable. I don't even know why you would compare a function. I'd expect comparison operators to be value types, data, strings, integers, dates, not functional things. I'm not comparing whether if I call get my message comes back with the same message. Who would expect that? Slice, map, and functions are not comparable. Maps, yeah, key value per. Slice, I get. Function, I get. However, in a special case, a slice, map, or function value may be compared to the pre-declared identifier null. Right. So if you have a slice, a map, or a function, but you just haven't initialized it yet, it can be compared. Ooh. Comparisons of pointer channels and interface values to nil is also allowed and follows some general rules. Right, am I right in thinking that what they're saying here is a comparison is okay? By the way, I've not promoted this. Let's go on to YouTube. I have two people who come onto this sometimes, so let's let them know. Everything's going to go a bit wonky whilst I do this, so just bear with me. Channel. Always a bit hesitant to type X into a browser, you know. my work monitor, my PC. So live coding, GoLang. Let's do it. Equals comparisons. Let's hit it up with a couple of mems. Okay, post. Honestly, watch my channel now light up like a Christmas tree as all my 2 subscribers come on. Gonna be awesome. Alright, so we're looking at comparables and we're looking at the different types, and it comes from this pull request where someone's done a check to see if a state is equal to a deep equals of that, rather than previously it was, state equals and then state equals the default object. The problem is that this thing contains a lot of stuff, and one of them I think is a key value per. And what we're saying here is there's quite a few things that aren't comparable. Maps aren't comparable, key value pairs, slices and functions. And then it goes on to talk about some of them are comparable if they're nil, right? Which kind of makes sense, because if something's nil, it's nil. You can check it quickly, it's done. But I don't understand why you would even put that into the language. So I'm wondering if I'm misunderstanding it or I'm getting the wrong end of the stick. If anyone's in chat, I would love to know. Just see what your opinions are, if we have any. I've got a couple of people on, but not very chatty at the moment. Right, so they're not comparable, and what I want to do is just run a couple of demos and just have a bit of a play about with comparison operators. And I'm just going to add some types and play about and see what we win, right? So let's head over. Forgot. Let's open you. Let's make you a little bit bigger. Channel can see. I think that's okay. So we've got a school. We've got an int, a name, and address. And these things are nil by default. And what we can do here is we can create a school. We commercially, do you know what? I'm going to take this stuff out because this was related to the dynamic type that I covered in the other video. So I'm just going to delete that. If you want to know about it, watch the other video. So what have we got? Let's take that out. Okay. That's used either. Let's delete that. Okay, so we've got a school A and B, and they're both syntactically identical. So if we're not equals, then we're going to say we're not equals. Then we're going to do a deep equals, and we should see if they're equal. Logic's a bit iffy. I apologise for that. School A and B, new school, completely default empty school. Check if they're equals and print out the results. Otherwise, we're going to use the deep equals. Let's just save that and run it. Input not used, encoding. Okay, no probs. So let's delete that, encoding. Okay, any errors? Nope. Okay, run. So schools are not the same. So a school with an ID of 1 and another school with an ID of 1 are not the same. I don't know what the hell's going on here because I've got an empty nil address. I ain't populated it unless it defaults to an empty, which I bet it does. Name is a string, ID is an int, they're comparable, but it says that they're not equal. Their schools are not the same. Then the next bit is schools are the same, and school are not equal, and then schools are equal. So wherever we're doing this reflect, we're using the reflect package to do a deep equals, then we're getting the results that we expect. That is equal to that because they are comparably equal. However, whenever we're doing if, we're not. So what I want to do is let's get rid of the address, right? Let's run this, see what we win. So not the same, schools are the same, not the same. So we're getting exactly the same results with pretty much just a struct with an ID and a name. Okay, so that's not what I've come to expect with this, what they were saying about equals. Once again, can't find in this. Struct types are comparable if all their field types are comparable. Two struct values are equal if their corresponding non-blank field values are equal. Fields are compared in source order, blah, blah, blah. And comparison stops as soon as they're not equal. So that's really not what I'm seeing. Let's get rid of some of this stuff. Let's clear it up. So let's change that. Equals. Make it a little bit easier to understand. Get in. See what we win. Going too fast. So schools are not the same, schools are the same. Okay, Let's do name equals John. Name 2 equals John. If name equals 2, then format, otherwise that. Let's see what we win with that. If I can come out of normal mode, edit insert mode. So names are the same. So if we look at this, we can see, and I did this before with runes, obviously characters, and I just started messing with characters. So what we've got is we've got equivalent equals being allowed with primitives like a string, and that's pretty cool. We don't have to do something weird like name dot is equal, which some other languages have. And what we can do is we can just see that name is equal to that. Okay, so let's take that out. Let's do, in fact, I should have just done var1 and var2, but hey, we live and learn. Var a equal IntelliSense knows what I'm doing, but my completer doesn't. Var1, and then var b equals 1. Word. What I'm going to do is I'm just going to check if var a is equal to var b. Var b my fingers just aren't being quick enough. Carpal tunnel. What do we get? It says names, but you know what I mean. Names are the same, and anyone who knows me will be highly irritated by this, but I always just do the negative test. In fact, I normally do the negative test first, just to make sure that things are working the way I'd expect. So names are not the same, variables are not the same, which is what you'd expect. 1 is not equal to 2. And, oh, come on, it goes too quick sometimes. Yep, names are the same. Awesome, I get that. Let's make a really, really primitive struct then. Create a struct with first name and surname. Why would I want it to just put the same comment in again? I mean, how on God's green earth is that useful? Into normal mode. Honestly, could have typed it myself by now. Literally like 10 times over. I mean, why? What? Why would I want you to just give me a string again? Oh, sorry. Type person struct. Here we go. First name. Maybe it was just having a sip of its brew or something. I'm not quite sure. Surname. Let's end this sucker. Okay, let's now create a person. So Every time I've got to stop myself from doing the something. Really. Person A equals new person. Let's yank that. Let's pay it in. Let's change you to B. Why is my line endings doing that? I should be always 5 down. Yeah, I'm irritated by that. I should always at least be able to see 5 lines down. I suppose that's the rule when we get to the end, I suppose. So if we look, you've got lines, I should always be able to see 5 up and 5 down. That's not working. Don't know where that's gone. And it's annoying, it's annoying, it's annoying. Just stop and have a look. No, let's finish what I started. So if person A equals person B, then the people are the same. We have the same peoples. Me and you have the same peoples. So look, do we have the same peoples? Do we? No. Peoples are not the same. Oh dear. What a shame. We cannot find our people, I'm afraid. So let's swap that. Well, there's a lie, isn't there? There's a lie, a stick lie. It said if the primitives that are comparable and the struct has primitives that are comparable with strings, we just proved that. We just honestly, we just stinking proved it like 2 seconds ago. Now we've got a struct of people, a struct, yeah, person struct with 2 strings. We checked if they're equal, and they're not. Well, what's going on? What's happening? What's going on? The structs are comparable if all their field types are comparable. So likely the documentation's wrong. You know, I'm telling you now, it's me. It's me that's wrong. But how? So the comparison of 2 interface values with identical dynamic types causes a runtime panic. Oh, if the types are not comparable. Wow, that's interesting. So you get an actual proper runtime panic if you try and compare dynamic types. Oh, that's pretty severe, that. With behavior applied not only to direct interface value comparisons, but also when comparing arrays to interface values or structs with interface value fields. Right. Honestly, anyone in the chat who gets this, let me know. Let me know. Give me some details. Give me some information. My Slack's blowing up, but no, my chat is a little bit quiet. Hello? Is there anybody out there? Let's see. Honestly, I don't know what's happening to Slack. Just give me a sec. Looks like the world's ended for some reason. No, 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 we're good. We're good. We're good. Nothing to worry about. Nothing to see. Awesome. Right. So compared strings, I compared slices, and I did maps. So we've done this, yeah, with the comparison for booleans and ints, structs, conditional operators, struct points, pointers. We can start looking at address operators. Okay, that's a good one, because did I do address operators? I think I would, yeah. Okay. Except pointer references are comparable. So I think you can just do that. Insert. Come on. Honestly, me and you are going to fall out. I'm trying this new thing, complete Vim completion, and I'm not seeing it. See, for God's sake, it doesn't cancel. When you cancel, it doesn't cancel. It doesn't go into normal mode. You've got to like click cancel twice. I don't like it. And then it puts in this extra space. It is driving me insane. I'm gonna have to uninstall it. It is winding me up. Persons are the same. Are the same. Are the same. Are the same. Right. Turn my phone off. I just don't know what they're up to. Honestly, give me 30 minutes. Give me 30 minutes. Can I have that? Can I just have 30 minutes of rest? So person A, person B, rest, doing other work, rest. Person A equals person B, so we're just passing it as reference, so we're not passing a pointer, we're passing a value type. And then when we pass a value type, we are equal. Okay. So maybe the problem is with the way I dereferenced it. For operators of x of type, for x of type t, the address operator and generates a pointer of type t to x. Is there a need to word it like that? Honestly, do you get like 10x developers to write the docs and then they just go blah, 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 blah? Just, I know we're devs, but just try and make it so that we don't have to have NASA IQ in order to read docs, please. I get it, but it's a bit much. So the operator must be addressable. Yes, that is either a variable pointer or indirection, or slice indexed operation, or a field selector of an addressable struct operand, which is what we had before, which is the way he wants it. Or an array index operator of an addressable array. Do you know what? What I'm getting to here is I'm getting to the point of comparing stuff is hard. We need to be careful. So whenever I'm typing this equals this, then I need to stop and have a little bit of a think about it. Or just use deep equals. So for an operator at x of pointer type t, the pointer in direction x denotes the variable of type t. Yeah. So we get a pointer. So if we get the address of this becomes the pointer by denote. Then if we dereference like that, maybe we get the same outcome. Yeah, persons are the same, which is what I expected. But you got to be careful, because of course these aren't the same address, because they're two different blocks of memory, of RAM. So you're going to get a different pointer reference. So I wonder whether when we didn't have the dereference, that we were actually comparing the address location and comparing if them address locations were the same. That's what happens in C++, right? You get a pointer and you get an address object, So the same's going to be true in Go. They're not going to have reinvented the wheel. It's just fundamentally how RAM works. You know, if you look at it from an assembly point of view, you just get blocks of RAM memory. So that makes sense. Now, what I want to do now is just change something. Delete word. Delete word. Do you know what? It really does. Delete in word. Thank you. Fingers will eventually do as they're told. So John Smith, like that. Let's run it. Right, here we go. So I was wrong. Documentation was right. So first name John, surname Smith is of course not equal to John Doe. So we've got persons are not the same, which is exactly the way we want it. We shall have it. We shall get it. We got it. We got it. We got it. Now, if I then put in something crazy, what was it that's not comparable? What was it? Come on, tell me. Tell me. It was slices, wasn't it? They're not comparable. How do you even put a slice in? How would you update an array object to be a slice object of a type like that? Not slices are not. Slices are not. Types are not. Slices and maps. Right, okay, we can put a map in, can't we? We can put a map in, he says. So if we look at try GoLang, we'll look at a map. Map is just a key value pair. Go by examples, probably a better way to explain it. So imagine you've got a identifier, something unique that says who you are, like your national insurance number or maybe your phone number, and that's you. Well, you could put your phone number there and your name here, or you know, you're not going to change your name very often. You could put your phone number there and maybe your bank balance here. You can keep updating it, and if anyone needs to look it up, they just type your phone number in and boop, out pops your bank balance. Why that would be useful, I don't know. You know, people build these crazy shit. It's fine. So they're saying, unfortunately, maps are not allowed, or at least not comparable. So what I want to be able to do is put a map into the struct. Okay. So bank balance. Bank balance is a map of string float 64. Not my bank balance. Okie dokie. Save that so it formats. Save that so it formats. Maybe format buffer. Thank you. Invalid operator. Oh, right. Okay, so that's really helpful. So we've got a message that's coming up to tell us that struct contains a map. and it cannot be compared. Does that run? Right, run. Come on, back. So we have got a really nice compile time check for that, which is really, really, really useful. And you know, maybe there should be a warning about pointer comparisons. Of course, pointer comparisons are useful, but you could maybe put your language in an unsafe mode or something to denote that you really know what you're doing. you know, it's the lifting the lid off the nuclear power button. Nuclear, launcher, and you just, I know what I'm doing. I'm going to press this button. It allowed me to do a pointer check and just didn't even sniff. But it must be that structs and maps are just completely uncomparable. So it throws a warning. I like it. I like it a lot. So you can replace this, right? So if we do go to insert mode and go to reflect, deep equals, have one of them, have one of them, and have one of them. Save it. Let's format buffer. Let's make sure it runs. And persons are not the same, and they're not the same because, of course, John Smith. Let's change that. Deleting word, insert done. Okay, run. Persons are the same. And I'm wondering if it will then check the key. So if I go, what we're looking for, what was it? Bank balance. Actually, bank balance is lowercase. Just come out of normal mode, for the love of God. Bank balance. Key. What do I want to do? Well, it's not used anywhere, so I'll come back to that. Replace that with a B. Okay. Looking at 22 down and end set. So we're looking for bank balance of 07525027555. I thought, you thought then, bet you thought I was going to put it in, didn't you? I know what you'd be doing. No, I know what you'd be doing. Like when Facebook, there was a presentation going on, and they were doing a live demo, and he was going really, really quick, and a pop-up came up, and he was putting his username and password in, and then another pop-up came up in front, and it just so happened to highlight then a text box, and he typed in his password into the text box on a live presentation. It was brilliant, absolutely brilliant. The look of sheer terror in his face was just awesome. What did I get to there? They weren't equal. They weren't equal. Persons, peoples, yous are not the same, which is the way I'd expect. So let's easiest thing to do is to actually just maybe yank that and put it in again. Maybe not that often. And delete that one and change you to be A. Why do you keep disappearing? Go. Persons are the same. Right, I'm going to play about, go a bit deeper, but I actually think we covered something pretty good there. Looking at the comparison operators, I love the fact that the language just says, no. Maps, you're trying to do it. We're not having that. We're not even going to allow you to do it. I would love warnings more on other comparison operators, other types where you're doing a double equals just to say, are you really sure you know what you're doing? Pointer references, like where you got the pointer and you're doing a comparison on the pointer. There are some complex stuff that people are doing, but I think on the vast majority of people who do that, they're not comparing the thing that they think they're comparing. Actually, something else is going on. And the fact that I'm actually seeing it in very good, amazing open source projects that have got some just fantastic people working on it, kind of makes you think that it's maybe a problem with GoLang. Now, I know it sounds crazy, but I don't actually do a lot of comparison operators in my code. I'm not a fan of if statements. But bear with me. If statements are a branching conditional logic. You do this or you do that. Now, normally there's better ways of doing it. Normally you can abstract that away behind types, behind dependency injection, so that you load the appropriate object based off the condition. Now, of course, your conditions have got to be somewhere, right? Your logic's got to be somewhere. But I hate code that's scattered with if statements, especially if the code is beginning to go like that. That just gets a little bit much. But all in all, I think that was very useful. So, as always, what we're looking at is my name is